Hello again, everyone, and welcome back to our course in college algebra. Tom McNamara here again, continuing our work with rational functions. Let me make my window as big as possible there, and let's kind of draw that to the front. You need to see me. Okay, so we got that. Great. So I wanted to go over some of the questions you'll encounter on My Math Lab. Make sure you're prepared for the way they word things. Okay, we have been talking about these rational functions and going over the key features of their graphs. And if you can summarize it in one word, the most important thing to figure out when you're dealing with a rational function is what are the asymptotes? Now you have two varieties of these asymptotes. You have vertical asymptotes, which are vertical lines that the function cannot cross, and you have horizontal asymptotes. Now, the horizontal asymptotes are more like telling you about the long-term behavior of the function. For big x values, does the graph flatten out to a certain level? If so, that's your horizontal asymptote. So, let's look at this here. It says, identify the horizontal or vertical asymptotes of the graph, if any. So, in this problem, we are not given the function's formula, we are given the function's graph. If you remember, one of the early themes in the course, having the graph is just as good as having the formula. Okay, we can see a lot of stuff right from this graph. Okay, I see a horizontal asymptote right here at y equals 5. I see a vertical asymptote right here at x equals 2. So this question is really a breeze. Not much we have to do. The function has one horizontal asymptote at y equals 5. Notice it wants us to type an equation. Okay, and if we pull this up, we see the equation of that line is y equals 5. Remember, horizontal lines involve just y. Vertical lines involve just x. That'll come into play later. Okay, so notice we did have the option of no horizontal asymptotes, but that's not what we're seeing in the picture. So we select what we see. Okay, great. We got it. Wonderful. The next part of this question has 3 parts, as you can see right up here. Determine the vertical asymptotes. Select the correct choice below. Okay, the function has one vertical asymptote, and I think we decided it was at x equals 2. Remember, once again, it's asking us to type the equation of the asymptote. So if you just type a number, it's not going to accept the answer. And to type the correct equation, you have to remember that for a horizontal line, y equals constant. For a vertical line, x equals constant. Okay, state the domain. Remember, the domain of a rational function and the vertical asymptotes of a rational function are intimately related. You typically get a vertical asymptote at x values that are excluded from the domain. So I know that we can't have x equals 2. So the domain is all x such that x is not equal to 2. Okay, they're using something called set builder notation for stating the domain right there. So this is our selection. All x such that x is not equal to 2. Great. I wanted to go 2, 3, 4, 5, 6. I wanted to go here and do another one here. Okay. Once again, they're telling me, they're not giving me the function's formula. They actually want me to come up with the function's formula. Okay, so they want a vertical asymptote at x equals 4. So let me write some notes here. Let me pull up my document camera. Oh, I went away. Document camera, go up there. Go above the window capture. Okay. So we want a vertical asymptote at x equals 4. Okay, now we know vertical asymptotes come from x values that make the denominator equal to 0. So if I'm going to have this happen, if I'm going to have a vertical asymptote at x equals 4, this has to be my denominator. Okay, my denominator has to be x minus 4. So let me switch back and look at the choices they're giving me. Okay, this is a possibility. B and C are both out. Okay, they have x minus 4, yes, but the x minus 4 is up in the numerator, and we know it's got to be in the bottom because the vertical asymptotes come from the denominator of our rational function. So B and C are both out. So process of elimination, we're looking at A, we're looking at C. Or sorry, we're looking at A, we're looking at D. Now, how do we distinguish between the two cases? Well, it comes down to the horizontal asymptote. They tell me I have a horizontal asymptote at y equals 2. All right, now, if we look back at the various cases for horizontal asymptotes, we saw 3 cases, right? Larger degree in the denominator, y equals 0 is your horizontal asymptote. Same degree, you got lead coefficients. Numerator has a larger degree, there is no horizontal asymptote. Okay, so let's go back to our choices. Over here, numerator has larger degree, so this will not have a horizontal asymptote. Here, numerator and denominator have the same degree, so the ratio of the lead coefficients would be my horizontal asymptote. What's my leads? Well, lead coefficient up top is 2, lead coefficient down here is 1, ratio is 2 over 1, which is 2. There's your answer. Okay? So, given what we know about rational functions, I can give you the formula and ask you to draw me the graph, labeling the vertical and horizontal asymptotes. Or I could give you the graph and ask you to tell me about the formula. Okay? Which is what we just did. So keep that stuff in mind. Remember, you can handle all the exercises in this My Math Lab set that I'm assigning you by using the principles that we've discussed about finding vertical asymptotes. And remember, to find vertical asymptotes, you figure out where the denominator is 0. And figuring out horizontal asymptotes. And there you're looking at the ratio of the lead coefficients. Okay, so think about those principles and you can answer every one of these questions.